Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of increasing, decreasing functions and concavity. So as per the problem, the graph of the function y equals f of x has local extrema at points a, c, e. So they are given in the graph a, c, e, and the points of inflection at b and d. If A, B, C, D, and E are the x-coordinates of the points, they are given on the x-axis, state the intervals on which the following conditions are true. So let's start with part A. So as per part A, the first derivative is equal to 0. So that means the function is increasing in that interval. Increasing function means that as we go from left to right, the curve is sloping upward or the y value is increasing from left to right. Now the second condition is and the second derivative is greater than 0. So that means on that interval the curve should concave up because the second derivative is greater than 0. So we have to find the interval in this graph where the function is increasing and it's concave up. So the part where the function is increasing and it's concave up is from point A to B, because as we go from point A to point B, the y value is increasing, the curve is sloping upward, and the curve is making a smiley face. So that's why the first interval for part A is that x is between A and B. Now the other interval where the function is increasing and it's concave up is from E onwards to the right side, because from point E the curve is going up as you go from left to right and it's making a smiley face. So that's why the other interval for part A is x is greater than E. So we're done with part A. Now in part B, the first derivative is greater than 0. That means the function is increasing. And the second derivative is less than 0. That means the curve is concave down. So we have to find the intervals in which these two conditions are satisfied. So increasing function means that as you go from left to right, the curve slopes upward or the y value increases. So that's from B to C, because as we go from point B to point C, the curve is going upward and the curve between B and C is making a frowny face. So that's why the interval for part B is x is between B and C. Now there is no other interval in which the function is increasing and is concave down. Now we can analyze part C. So in part C, the first derivative is less than 0. That means the function is decreasing. And the second derivative is greater than 0. That means the function is concave up. So we have to look for an interval in which the function is decreasing or it's going down from left to right, or the curve is sloping downward, and it should also concave up. Now to the left side of point A, the curve is going down or sloping downward from left to right, and it is making a smiley face. So that's why the first interval for part C is x is less than a, because that part of the curve lies to the left side of a value. Now another part where the curve is decreasing and its concave up is from D to E. So as we go from D to E, the curve is sloping downwards and it's making a smiley face, or x is greater than D and less than E. So these are the two intervals for part C. Now part D. So the first derivative is less than 0. So that means the function is decreasing. And the second derivative is less than 0. That means the curve should concave down. Now we can analyze the given curve. So the function should go down or slope downward from left to right, and it should make a frowny face. So that's from point C to D. So the first interval is x is greater than C and less than D. Now there is no other interval where the function is decreasing and it's concave down. So this should be the final answer for part D. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.